right, today's lesson is reflections, day 2. Reflections do not only occur in an axis, reflections can occur in any line, horizontal, vertical, or even diagonal. Write an equation to describe each graphed line. I'm going to leave this for you to do, and it's the first thing that we'll go over in class. You're going to write the equation of the lines that you see in these 4 examples. So I'm going to go on to number 1. Number 1 says the positions of 2 sticks AC segment and BD segment are shown in the coordinate Cartesian plane. Draw the images A prime C prime segment and B prime D prime segment with y equals 1 as the line of reflection. Well, hopefully you remember that y equals 1 is this horizontal line. That's not the x-axis. Y equals 1 is 1 above that. The x-axis is y equals 0. So now our line of reflection is not the x-axis, but just above it. So I'm going to start and I'm going to reflect each of those points over the line of reflection. So they have to be equally distant and perpendicular to that line of reflection. So starting with A is 3 above, so I'm going to go 3 below that line of reflection, y equals 1, 1, 2, 3, and I get the point -1, -2 is A's image. B is sitting on the y-axis 2 above, so I'm going to go 2 below y equals 1, and it's now at 0, -1, B's image. C is 1 above the y equals 1 line, so it's going to actually move on to the x-axis 1, 0. So that's C's image. And D's image is 1, 2, 3, 4, 5 above, so I'm going to go 5 below, 1, 2, 3, 4, 5, and it's going to go to the point 2, -4. That's D's image. Now I'm going to use my straight edge, and please use a straight edge to connect these. AC and BD, and your figure should look like that it's reflected over that line y equals 1. And make sure you put all those prime marks. Let's go on to number 2. Number 2, a graphic designer is designing a logo in a Cartesian plane. Some of the points are at A is -1, 5, as we can see. B is -1, 3. C is -3, 1. And D is 1, 1. Draw the line x equals 2 on that same coordinate plane. So x equals 2, I'm going to go ahead and draw that line x equals 2. And my line doesn't look very straight there. Use a straight edge and draw that. X equals 2. So it's 2 away from the x equals 0 y-axis. So I'm going to start with point A, which is 1, 2, 3 to the left. So I have to go 3 to the left of x equals 2, which is x equals 5. So A's image is now the point 5, 5. B is 3 to the left, so I'm going to go 3 to the left of x equals 2, and it's going to be the point 5, 3. B's image. C's image is 5 to the left of x equals 2, so I have to go 5 to the right of x equals 2, so that's going to put me at 7, 1. And D's image is only 1 left, so 1 to the right would be 3, 1. So I'm going to use my tool, and you're going to use a straight edge, and I'm going to connect A to B, B to C, C to D, and D back up to A. And yes, they should look like it's a reflection, congruent figure to the coordinates that you had. So now I'm going to fill in my coordinates. I said A was 5, 5, and B's image was 5, 3, and C's image was 7, 1, and D's image was 3, 1. Number 3. A symmetrical object, ABCD, is drawn on the coordinate plane. 3 vertices of the object are at positions A, -3, 3. -3, 3. So that's A. B is at 3, -3. So 3, -3. C is at 3, -5. Draw and label points A, B, and C. Okay, I did part A. That was easy. Point B is the reflection of point A in the line of symmetry. Find the equation of the line of symmetry. Let's see. Okay, so I went from A, which was -3, 3, to B, which is the inverse, 3, -3. So my y became my x, and my x became my y. Oh, the line of symmetry is y equals x. So they were reflected over the line y equals x. I'm going to use my line tool here. Y equals x. So that is this line here, y equals x. Y equals x. Right? The y equals the x and the x equals the y. That makes sense to me. So there, A was reflected over y equals x to become B. So find the coordinates of D. Well, if C is 3, -5, then y equaling x, D should be -5, 3. They exchange places. So -5, 3. That would be D. That makes sense to me. Are they equally distant and perpendicular? So what I mean by perpendicular, do they cross at 90 degrees? So I'm just going to pick a different color to show you that if I was drawing this, yes, that would hit at 90 degrees. Whoop, that should hit at 90 degrees here. There we go, that's better. And D and C should be hitting this y equals x at 90 degrees as well. So there's a 90-degree angle here, and they are equally distant. I'm not going to do number 4 because I want to show a couple videos on symmetry tomorrow. So that's it for today, and we'll go over our notes in class.